Hey there, Maniac, welcome. So, on the Parkinson's disease video, which was the last video, I said it's the second most common neurodegenerative progressive disease in the world. And I also mentioned that on the next class, we're going to be talking about the most common, the number one neurodegenerative progressive, the number one dementia in the world, which is the Alzheimer disease, which is exactly the topic of our class today. So, I just want to make sure that you guys remember what is a neurodegenerative progressive disease, which is a disease which causes the loss of neuron mass, which causes some neurons to die and spreads throughout the brain as time passes by. So neurons do not have the capacity to reproduce in themselves. So once they die, there's no turning back. There's no way to bring the neurons back. That's why neurodegenerative progressive disease, that's why dementia diseases are treated at once. And dementia is going to be given in three different ways. They can be either they can be either muscular, which is the case of Parkinson's disease. They can be from hearing. They can be the most common one, which affects even 10% of people aged 65, which is the Alzheimer disease, the most common neurodegenerative progressive disease in the world. So first thing that I want to do with you guys, I want to compare the healthy brain with a person that holds the Alzheimer disease. And okay, I just want to make sure that you guys understand about these three parts of the brain. I want to emphasize them, which are the vesicles. The vesicles is kind of like an empty space of the brain. It has some functions, but do not have the vesicles just for nothing. It's like this empty part of the brain. We also have the hippocampus. I've already recorded a class talking about the hippocampus. If you didn't watch it yet, you should watch that. And like the hippocampus, the main function of that is to store short-term memories. So you guys must be relating it the Alzheimer's disease with the hippocampus loss. We also have the cortex, which is like the superior part of the brain, the superficial part of the brain. And I just want to compare this, which is a healthy brain, with a person that holds the Alzheimer's disease. As I said, there is a usually neuron loss, so consequently they have this diminutive size brain because they do not have as many neurons in their brain, so most of the neurons. So the first thing that happens is the vesicle increases. Vesicle is an empty space, so it increases. That's not good enough for a brain. As much as the vesicles increases, these two parts of the brain, the cortex, increases. So the facial part of the brain, which has a lot of functions of the brain, increases. So as time passes by, over time, people who hold the Alzheimer's disease, they end up losing a lot of these functions to the cortex. So the cortex decrease. As much as the hippocampus decreases, the hippocampus is responsible for storing short-term memory. Once it decreases, once there's no hippocampus anymore, there's no way of storing short-term memory, it is definitely going to be jeopardized. So we don't know what causes neuron loss, but there are some theories why this happens. And for us to understand it better, we have to understand about two things that kind of bother the neurons that make them work that well, which are neurofibrillary tangles and the placos. The neurons do not only send action potential to one another. They have to send some essential molecules to one another in order to keep surviving. They have to send some essential molecules. And they do it through a protein-based structure that kind of gets bothered where a person holds the Alzheimer's disease, which is what we call the neurofibrillary tangles. There's number one here. It's made with bothers this road in which the proteins and the essential molecules passes by. This kind of bothers the molecules going through, which makes the neurons not be able to communicate, not be able to send the essential molecules down the board. As much as we have the tangles, which really bothers a lot of the neuron, we also have sparkles like this. By the end of the neuron, the cytoplasm vat, we have this protein-based stuff as well, which sends the proteins, which send the essential molecules that are getting bound to the whole synaptic neurons that are in front of this one. By on the Alzheimer's disease, they end up going pretty much folding. Consequently, they end up getting together and forming a huge misfolding black hole, which bothers the other molecules going through. So besides the tangles, we also have black holes when a person holds Alzheimer's disease, which really bothers the communication between the neurons, which really bothers they send molecules to one another. Okay, but what exactly kills the neurons? It's not known by neuroscience yet. There are two theories about it, which is a increase and decrease of two neurotransmitters. The first one is acetylcholine. Acetylcholine, actually, I forget to pronounce it back. But acetylcholine is a excitatory neurotransmitter. It means that it plays some roles in our brain, and one of them is rewarded to memorize. It tells the neurons what they have to do, but one of them is about memorizing. So once there's few acetylcholine, you have like many functions lost, the brain many functions that your neurons are not able to hold anymore. But there's something we can do in order to treat it. There's something called acetylcholine eraser, which is responsible for like killing the acetylcholine to make sure there's a good balance on that. There's not going to be too much acetylcholine in the brain. So what we have to do, we have to find a way of inhibiting the acetylcholine eraser. Consequently, like the amount of acetylcholine is going to increase, but it's just a way of treating. We have treating that. We have to make sure the acetylcholine is going to be up, it's not going to decrease for as long as possible. That's a way of treating the Alzheimer's disease. But as I said, it's going to be just a way of treating that. There is no way of curing it or stopping the neurodegenerative progression of the disease to keep spreading the brain. There's no way of turning the neurons back, okay? Not yet. Maybe one day we're going to be able to do this, hopefully. As much as we have an increase on glutamate, which is another excitatory neurotransmitter. Okay, but increasing it wouldn't be good. It wouldn't make the neurons talk, they conversate, they send signals to one to others faster. Wouldn't they work faster? It doesn't work like that, because if you guys remember the action potential class, glutamate binds to the receptor, but it opens some gates of some molecules joining sodium and calcium. One of them, as I said, is calcium. So once it gets here, it goes inside of the cell, it's going to stimulate inside the signal. So it's the most important we have the calcium inside of the cell. But as there's too much glutamate bounding into the cell, because there's an increase of glutamate neurotransmitter in the brain, one person holds the Alzheimer's disease. There's going to be too much calcium going inside of the cell as well. This is not good because the neuron is not going to hold that much calcium, which results in the neuron dying because of calcium overdose. So that's it for the Alzheimer's class today. Hopefully you guys learned something new. Hopefully you guys liked the video. And yeah, see you later. Thank you for watching.